We're looking at arithmetic sequences. Okay? And a sequence is a list of numbers. So I'm going to give you an example of an arithmetic sequence. Very simple one. Okay? And this continues on forever. There's a lot of uses for this in higher level mathematics. It's kind of hard to see, but it does come up quite a bit. And so when we're looking at this, okay, so it's a sequence. It's basically a list of numbers with some sort of a pattern. Well, the arithmetic part comes from adding, okay? So if I look at this and I want to tell what type of sequence it is, because there are different types, if the amount that I add or subtract, what we call the common difference, is the same, then it is an example of a arithmetic sequence. So you can see here, every single time I add a 5. So we use a D to represent that. So I have a common 5. So every time that, since I add or subtract the same number every time, that's an example of an arithmetic sequence. So there's a lot of notation with this, and it really throws a lot of people off. So let's look and see if we can kind of understand it. So you have an issue of term numbers and term values. Okay, so let's kind of make a chart out of this. So I'm going to call this the term number. Okay, and that's what we're going to use as n. That's the notation that we use for that. And then there's the term value. Okay, and we use the notation, the function notation, a of n for that. Okay, well, I'll give you some more explanation on that in a second here. So looking at this, okay, well, the first term is 3. Okay, so if you just look at my sequence here, the very first number is 3. The second term, the term number, the second term has a value of 8. And then the third term has a value of 13. And then the fourth term has a value of 18. Okay, so you can see these are the term values, what they actually are, and this is their number in which they pop up. So the fourth term is 18. Okay, so the way that you see this written is with your n's and a of n's. So if I said a of n, okay, or a of 1, that means what is the first term? And that's 3. I could also say, okay, well, it's a of 2. That's asking me for this sequence, what is the second term? In this case, it's 8. And then a of 3 is 13. And a of 4 is 18. So that's a little explanation on the definition and the notation. Okay, so this tells me it's the first term, and that's actually what the first term is. Okay, let's do the same thing. So we did a couple of important things. We found the common difference, and we expressed it in the notation. So let's look at another sequence and try to come up with the same stuff. So looking at this, if I give you something like -2, -5, -8, -11. Okay? So when I'm looking at this, I want to look at, okay, let's look at the term numbers and let's look at the term values. So the term numbers versus our term values. Okay, so we have the first term is -2. The second term is -5. The third term is -8. And the fourth term is -11. Okay, so I kind of made the assumption there that it is arithmetic. So let's just check it to make sure. So this is kind of weird. It kind of throws people off. So let's look and see what the change is. I'm talking about from here to here. And a lot of these you can see by looking at them, but some of these sequences get more complex and it's a little bit harder. But one of the ways you can always do it is always the next term before the first term, what I like to kind of shorthand and say the right one minus the left one. So if I do -5 minus -2, add the opposite here, that's -3. Then I do it again, -8 minus the term before it. You can see here, oh yeah, I'm going to subtract 3. If you look at it, yeah, I'm increasing by 3, but it's negative, so I'm really subtracting 3. So my common difference here is a negative 3. So I'm going to say D equals negative 3. And it's the same number, right? The sequence is getting smaller. Okay, the sequence is actually getting smaller, right? A bigger negative number is actually smaller. Okay, you kind of understand what I mean by that. So let's list this notation in the function notation, right? So a of n, right? And when I say of, that means a parentheses, and the n is what term it is. So what is a of 1, which is the fancy way of saying what is the first term, and it's negative 2. What is a of 2? Right, and that's negative 5. That's the second term. And as you can see as I move on, a of 3 is negative 8. And a of 4 is negative 11. Okay, so we're going to do some formulas here eventually, and we need to understand this notation so it makes sense.